So let's just summarise what we've learned so far about breathing physiology or breathing chemistry. Overbreathing is a problem because it significantly reduces oxygen delivery to the brain and so compromises brain performance. It's triggered by emotional influences such as stress or any sense of threat. It's a matter of degree. There's a spectrum of dysregulation from severe to mild. Overbreathing can be context dependent, that is, triggered by circumstances but relatively short-lived, or it can be habitual or chronic. Even when it's chronic, it's likely to be better at some times than others. And when it's mild, you don't necessarily know anything about it. In my experience, it's common for my clients to have no idea that they're overbreathing. And that raises the question of how do you actually know? No surprises here. I think the best way is to measure it using a device called a capnometer. A capnometer samples the air that you breathe out and it measures the concentration of carbon dioxide. It's not foolproof as a means of assessing overbreathing because it only gives you a snapshot in time. If you dip in and out of overbreathing, it won't necessarily pick that up. But the main point here is that it works as a powerful biofeedback device. That is, it's able to pretty much instantly detect the variations in breathing that are associated with stress levels and the like. This is a screenshot from biofeedback software showing the trace the capnometer generates. You see that you get a sequence of peaks, one for each breath. Clearly the carbon dioxide peaks in the exhalation, in fact at the end of the exhalation, and then it drops to zero when you're breathing in. Now, the distance between peaks gives you the breathing rate on a breath-by-breath basis. But the really significant parameter is the height of the peak. That height is known to correlate with the concentration of CO2 in blood, which remember is the significant thing physiologically. So that means the higher the peaks, the better. The peak value is called end-tidal carbon dioxide, and the software detects the peak value for every breath and it keeps track of this in another graph. Loosely speaking, when the peaks drop below this dotted line that you can just about see here, which is at 35 on this scale of 0 to 50, that can be considered as a degree of overbreathing. So in the example, there's a brief period of overbreathing here, only for a few breaths. It also corresponds to faster breathing, as you see because the peaks are closer together.